Hello and welcome. This is Columbia Basin Research's third video in a multi-part series on using Program SURPH. Program SURPH is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences. Program SURPH, Survival Under Proportional Hazards, was developed to analyze data from the release-recapture studies of animal populations, in particular to relate the survival estimates from release-recapture studies to individual-based and group-based covariates. Today, in this third video, I'm going to show you how to create models that will help parameterize your results. Future videos in this series will focus on the results as well as offering various hints and tips on getting the most out of the program. Alright, so let's fire up the program. SURPH uses the term models to encapsulate a particular parameterization of detection, survival, and product probabilities. When the parameters are estimated, the parameter estimates are stored as results. Today, we'll look at creating the models. SURPH supports two approaches to modeling. Number one, joint survival and capture modeling, when the survival and detection probabilities are modeled concurrently. Number two, two-stage modeling, when the detection probabilities are modeled independent of the survival process. Once an appropriate model has been selected for the detection probabilities, the user then models the survival and product probabilities. Later in this video, we'll describe the joint modeling process and the two-stage approach to modeling. First, however, let's look at setting the model parameterization via the effects dialogs. Here you can see the effects section of the SURPH navigation panel. Under define model, there are three main sections: detection probabilities, survival probabilities, and final product probabilities. Each section has effects dialogs for the main effects, the group covariates, and the individual covariates. A right-pointing caret indicates which effects dialog is currently active, if any. Here, the main effects dialog for detection probabilities is currently active. Next, we can see the effects control buttons, providing shortcuts for setting commonly used parameterizations. The buttons affect the currently active effects dialog and are as follows. Number 1. 0 sets the values in the active covariate or individual covariate effects dialog to all zeros, indicating that the covariate is not to be included in the model. If a main effects dialog is active, the 0 button is grayed out or disabled. Number 2. Common sets the values to all ones, indicating a common parameter across all populations and intervals. Number 3. Population specific assumes a unique parameter for each population and common parameters across intervals. Number 4. Interval specific assumes a unique parameter for each interval and common parameters across populations. Number 5. Population interval specific assumes a unique parameter for each population and each interval. Next, we can see the main effects window for a dataset with 10 populations and 3 intervals, 2 intervals for which the survival probabilities are estimable. In this case, the main effects are set for population and interval specific models. This is the population interval specific setting corresponding to this table in Appendix B211 of the manual. This fully parameterized model is equivalent to the CJS model, with unique estimates of survival for each population and interval. It is the default setting for the main effects window and can be set via the population's interval-specific effects control button. Here we can see the main effects dialog with a common parameter for each population and interval. It can be set using the common button and corresponds to this table found in Appendix B212. The common model has a common parameter across all populations and intervals. Next, we can see the population-specific parameterization set via the population-specific button corresponding to this table in Appendix B213. If we assume that survival differs across populations, but not from one interval to the next, the survival probabilities can be parameterized as shown here. Similarly, this shows an interval-specific parameterization corresponding to this table in Appendix B214. The interval effects model assumes unique survival probabilities from one interval to the next, but the survival probabilities do not vary across populations. Finally, we can see here a custom parameterization where unique parameters are assumed for each interval. For the first 3 populations, a common parameter is assumed across intervals for populations 4 through 6, and unique parameters across intervals for populations 7 through 10. These settings correspond to the table found in Appendix B215 of the manual. Note that the main effects dialog for the product term has a row for each population, but only one column. Group covariate effects and individual covariate effects are modeled in much the same way as the main effects, with the difference that the number 0 is allowed in a cell of a group covariate effect window, indicating that the covariate effect is not included for the given population and interval. If we click here, we can see the default settings for a covariate effects window, indicating no effects for the given covariate are included in the model definition. This can also be set using the 0 model effects button. Notice that the name of the covariate distance here in the tab at the top. If there is more than one covariate, there will be a tab for each covariate, and the user can select which covariate to work with by selecting the appropriate tab. Here we have the settings for a model definition in which the group covariate covariate distance is assumed to affect a survival in all populations the same way in the first interval and is assumed to not affect survival in the second interval. As mentioned at the beginning of this video, one approach to modeling is to model capture and survival, including product probabilities, concurrently. Joint survival and capture models are created by double-clicking Create Model under the Survival Modeling heading after all effects dialogs have been set as desired. SURPH will prompt the user for a unique name for the model. Once you create that, the model will appear under the Available Survival Models heading. Here we can see an example with two joint survival and capture models created. A green checkmark indicates the currently active model. All effects dialogs will always be set to the currently active model. The user can change the currently active model by double-clicking on the desired model. All currently open effects dialogs will be updated to reflect the currently active model. Thus, if the user wants to create a new model that is a slight variation on an existing model, the user must simply make the existing model active, make the necessary changes, and create the new model with a new name. Notice that the estimate action is now available under survival modeling. Whenever there are pending models for which results have not yet been calculated, the estimate action is available. Double-clicking on estimate will cause SURPH to estimate the parameters for all pending models. Doing so for this example will cause the parameters to be estimated for both full and common as shown here. Notice that the estimate action is no longer available and results distance full and distance common are now available under the results section. Results names take the form dataset name / model name. Note that the model may be renamed at any time by right-clicking on it and selecting rename as shown here. In the two-stage modeling approach, the detection probabilities are modeled first independent of the survival process. Once the detection model has been selected, the user can lock the detection only model and then model survival and product parameters. When create model is clicked under detection only modeling, a model is created in much the same way as described in the previous section, with a name appearing under the available detection models heading. The difference, however, is that only the detection parameterization is saved as a detection only model. The survival and product effects are not saved. As with joint modeling, the estimate action becomes available once there are pending detection only models. Double-clicking on estimate will cause the parameters to be estimated using the Manley-Parr likelihood described in Appendix B3. The Manley-Parr likelihood estimates the detection probabilities without reference to the survival process. The summary statistics used in the Manley-Parr estimates are Chi_IK, the number of animals marked before sampling event K in population I that were detected both on event K and at least one event later. Z_IK, the number of animals marked before sampling event K in population I that were not detected at event K but were detected on at least one event later. Rho_IK, the proportion of animals detected at event K in population I that were removed. Once results have been created from the detection-only modeling process, the user can lock the best detection-only result. See hypothesis testing for selecting the best model by right-clicking on it under Available Detection-Only Results and selecting Lock, as I'm doing here. Note that a detection result cannot be locked if there are existing results under Available Survival Results in the Results section. Once the detection-only result is locked, a padlock icon appears beside it in the Available Detection Models and Available Detection Results, which you can see here. At that point, the user can no longer make changes to the detection effects dialogs and can no longer create any further detection-only modeling or results. The user can look at the effects dialogs for the detection, but their settings cannot be modified. The detection-only results can be unlocked by right-clicking on it and selecting Unlock, as I'm doing here. If there are existing models under Available Survival Models that do not conform to the locked detection-only model, that is, their detection parameter settings are different than those of the locked detection-only result, they will be grayed out and no longer be available in the current dataset. After locking the desired detection-only result, the user can then model the survival and product parameters as described previously. This has been Lesson 3 on using Program SURPH, in which we've covered setting up your models. Future videos in this series will assist you in estimating results, as well as offering various hints and tips on getting the most out of the program. Please note that if for any reason you're having trouble with Program SURPH and these videos are not sufficient to answering your questions, you can find the user manual at cbr.washington.edu/analysis/apps/surf. The PDF manual is there, and you can either load that in a web browser, as I'm doing right now, or you can download it to view in Adobe. If you're using Program SURPH and you have any questions or comments, on that same page you may give feedback via our user satisfaction survey. We would greatly appreciate any feedback you have in helping us make future versions of this program to be more useful to our users. We hope that this video helps you get the most out of Program SURPH. Again, if you have any questions or comments in regard to Program SURPH, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck on your analyses, and thank you.